Good morning, students. Welcome to today's topic on closed cycle ocean thermal energy conversion under the course Renewable Energy Resources, course code being 216652. Myself, Dwarkanath SK, Assistant Professor, Department of Triple USC, Bangalore. So let's move on to today's topic of discussion on the closed cycle OTEC, how it works. As discussed in the open cycle session, the closed cycle here it will be a loop of it. So organic fluid which flows into a separate closed loop cycle, we call it as a organic Rankine cycle. Here warm seawater which is pumped through the another pipe which operates the working fluid into the heat exchanger to drive the turbine generator to generate electricity. The fluid pair which condenses into liquid form by the deep sea cold water is pumped into condenser to separate pumping system. This process of pumping liquid fluid into an evaporator cycle it is been repeated. We call this as a closed loop system. The schematic arrangement is as shown. I will just show in the next slide. It has a different compartments or different arrangements. The organic fluid with a low boiling point, which is used as a working fluid. The liquid fluid may be ammonia liquid, which is the most commonly widely being used. This working fluid just flows into a closed loop and perfectly sealed piping system. Working fluid just circulates around the loop continuously. Warm ocean seawater, which flows through completely separate piping system and it discharges into the upper surface of the ocean. This warm surface seawater and the working fluid they are placed very close to each other in a heat exchanger to transfer the warm seawater heat into the working fluid. This takes place. The cold deep seawater piping system is in contact with the working fluid piping system in a condenser where working fluid condenses to its liquid state. So let's see the working process of it. Initially, the working fluid, which is pumped through the heat exchanger in the cold loop cycle, which is perfectly leakage proof. Then the warm seawater, which is pumped through the separate pipe in the heat exchanger, is in contact with the fluid closed loop cycle. The heat is going to transfer to the fluid. This warm seawater transfers its heat energy to the working fluid in the heat exchanger. Working fluid vaporizes the liquid vapor which makes the turbine to rotate and which drives the electrical generator to produce the electricity. So next to this fluid vapor, it leaves the turbine in a cooled and condensed as a liquid fluid and it is pumped again to repeat the cycle. This cold deep sea water is pumped through the separate pipeline in a condenser to provide the efficient cooling of the working fluid, which is ammonia. So here is my closed loop OTEC. Initially the warm seawater, this is my inlet and then it is going to the heat exchanger and then it goes to outlet. In this heat exchanger, this energy from the warm seawater, it is passed on to the liquid fluid which is going and hits the turbine. From there power is being generated and output of the turbine it is passed on to a condenser. Here that heat will be retained. The cold sea inlet is passed on to it and then it goes back to it to retain that cold. Then it is pumped back once again into the heat exchanger to repeat the cycle. This system we call it as a closed loop OTEC system. Hope the session was very much useful to you people. Do subscribe to our department channel for lively updates. Any queries with respect to today's video, you can write down at warknath@sgbt.edu.in. So thanks for watching this particular video.